Suppose you have this picture right here. Make it look like that. Let's say this here is at negative 10, 0. Let's say the vertex is at negative 4, 3. And suppose that this is at 2, comma 0. And let's say the name of this graph is f of x. All right? Question A. When is f of x increasing slash decreasing? We'll use the abbreviations INC for increasing and typically DEC for decreasing. So when is this graph increasing? When is it decreasing? So when is this going up and when is this going down? Well, looking at the graph here, we can all see that it goes up during that time and then it shoots down during this time. So for the increasing, it increased up until you hit negative 4. So I could say this. It was increasing. We can say it was increasing when x was less than. When x was behind negative 4, before negative 4, we were going up. What about decreasing? We're decreasing afterwards. So when x is greater than negative 4, the graph is going down. So you're given the picture of f, and they want you to describe when f is going up and going down. What about part B? It says this: state the extrema of f of x. When they say extrema, they mean the extreme highs and lows. This picture, it goes down forever. So it doesn't have a floor, but it has a ceiling. It has a rooftop up here. So if you wanted to tell them like a maximum or a minimum, you could not tell them a minimum in this case because this graph goes down forever. So for minimum value, you can just say like none or no minimum. It does have a maximum. And usually you tell them where the maximum occurs. Where is the x coordinate? So you could say maximum at x equals negative 4. The actual maximum value itself, like the height or the roof, if you will, the ceiling, would be the y coordinate. But usually they ask you where it happens, meaning the x coordinate. So the point is, if you have the graph of f and they ask you for things pertaining to f, it's easy because you just look at the graph and say when it's going up, when it's going down, when's the highs, when's the lows. However, what if the picture you're looking at, check this out. What if you were looking at the graph of f prime and I wanted to know when f was increasing or when f was decreasing? But the picture is the picture of the derivative. Everything changes. So here are some facts that you should put on your notes here if you were absent on that day. Let's go to a graph like this. Make this picture. Let's say this is the graph of f of x. F of x. Put a point up there and then put a point down here. And notice here, if we go left to right, notice that right here the graph is going up, here the graph is going down, and here the graph is going up. So during this first time, during this portion there, the graph is increasing, f of x. You could say that f of x is increasing. In the middle, you could say that f of x is decreasing, it's going down. And then back here on this side, you can say that f of x is increasing. Now, here in purple, notice that, let's go back to the left. If f was increasing, notice that if I draw a tangent line anywhere during this time, that tangent line has a slope that's positive. And the slope is like the derivative. So when f is increasing, the slopes are positive, or that is the derivative. F prime of x is positive, greater than 0. That means positive. In the middle, when the graph was going down, f was decreasing, which implies that f prime, the derivative, would have been negative. Here at the end, f is going back up, f is increasing, is the same as f prime being positive. Now, a quick side note here in yellow, just a quick side note. You can just watch this part. Let's say you have a graph here in yellow. Just focus on the yellow real quick. If you have a graph, when the graph is underneath the x-axis, that's when the graph is negative. When the graph is above the x-axis, the graph is positive. So I want to make some more comments here back in our main section. So we said that f was increasing is the same as f prime of x being positive. That's the same as f prime of x being above the x-axis. The graph of the derivative being above the x-axis. Here in the middle, f prime is negative, means f is decreasing. That's the same as f prime of x, or the graph of it being below the x-axis. Here, f prime of x is below the x-axis. We can make some more comments. How about here in green? This guy, that's what we call a local maximum. Here in the bottom, this is a local minimum. Notice what has to happen for you to have a maximum. You have a maximum when the graph goes up to suddenly down. That is, when f prime goes from positive, f prime goes to negative. That's when you have a maximum. When do you have a minimum value on f? You have a minimum when the graph goes down to up, when the derivative goes from negative to suddenly positive. So let's summarize all of these facts with some sentences here. And this part is gold. So here are some facts. So let's say this. We can say that f of x increases when its derivative is positive, meaning when f prime of x is above the x-axis. Now, underneath, let's write the sentence like the opposite. We can say f of x is decreasing when f prime is negative, meaning when the derivative is below the x-axis. Some more comments here. We can say f of x has a maximum when what happens? F of x has a max when the derivative goes positive to negative. So f prime goes positive to negative. One more sentence. We can say f of x has a minimum. Under what condition? When the derivative goes negative to suddenly positive. Let me leave these facts there. And let's do some examples here in red. Is that red? That's red. Example. Let's say you're given this picture. Like that. Let's say, boom, just like that. Let's suppose that here, this is x equals 3. And suppose that this is the graph of f prime of x. You're looking at the graph of f prime. For part A, they want this. When is f of x decreasing? Question mark. We trust these green facts here above. So we want f to decrease. That's right there. So f decreases when the derivative is negative. In other words, when the derivative is below the x-axis. When is this picture below the x-axis? Right there. This part, this derivative is under the x-axis. That was before you came to 3. So when x was less than 3, when x was behind 3, the derivative was under the x-axis, below the x-axis, which means that f was decreasing. So that's how we use the graph of the derivative to describe things about the original function f. That's part A. Here's part B. Part B. When is f of x increasing? So all I see is the graph of the derivative, but I can still tell you where the original graph f was increasing because of the fact f increases whenever its derivative is above the x-axis. When is the derivative above the x-axis? It's above the x-axis when x is after 3 or bigger than 3. That would be the answer to that question for part B. What about part C? Part C says this. Describe the extrema of f of x. So the extrema is like the maxes and mins. So that's what these sentences here in green mean. So f has a max, f has a min when the derivative goes positive to negative or negative to positive. Well, this derivative, it goes from negative to suddenly positive, and that's it. So it goes from negative to positive, which means that f has a minimum. So f has a minimum here at 3. So we can say f of x, we can just say min, we can say minimum at x equals 3. So in this case, the graph of f does not have a maximum because the derivative never goes from positive to negative. It only goes from negative to positive. If you're feeling comfortable with this, you can exit now, but I will do one more example. Let's say you're given this, watch, here in yellow. Let's say your graph looks like this. Suppose the graph looks like that. And let's say this is at -3, and let's say this is at let's say 2. And you're looking at the graph of f prime of x. So question here, question A, when is f of x, when is f of x increasing? So let's see. So f increases when its derivative is above the x-axis. It's above the x-axis there, from -3 up to 2. So x is between -3 and 2. The derivative is above the x-axis, making it positive, making f to increase. Right? Part B, the opposite. When is f of x decreasing? Question mark. So when is f decreasing? F decreases when its derivative is below the x-axis. That means this tail and that tail. So that would be when x is before -3 and also beyond 2, when x is greater than 2. So this has two separate cases. When this happens and then when that happens. Okay, what about this? What about, yeah, look, the extrema. That's a good one. So part C, state the extrema of f of x, like the maxes and mins. So you're looking at the derivative, and we can see that the derivative goes here, it goes from negative to positive, and then suddenly it goes from positive to negative, because it goes from above and below the x-axis or vice versa. So when the derivative goes negative to positive, like here, there, that means f has a min. So we have a minimum at x equals -3. When the derivative goes from positive to negative, that means we have a maximum. So we can say that f has a maximum at x equals, in this case, +2, because that's where it's switched. Okay. Now, for part D, the last one, let me go back to the picture and let me add one more component here. Here in blue, let's say, put a point like right there. And let's say, put a point like right there, actually. And just pretend that the coordinates here are like -1/2, 4. It's not the best picture, but let's just pretend that's the vertex. So for part D, I think we're in part D now. It asks this. State the increase, decrease intervals of f prime. So now I want to know when f prime goes increase and then decrease, not f, f prime. Well, you're looking at the graph of f prime. See that? You're looking at f prime. So just tell me when that yellow graph goes up and when it goes down. So that graph, f prime, it would increase. I'll just put I for increase. It would increase before you hit the vertex. So for x's less than -1/2, because the vertex is at -1/2, before -1/2, we were going up. And then d for decrease, it decreases beyond the vertex. So for x is after -1/2. Okay. And then actually, you know what? Let me add some more to this. Let me take away that vertex. Let me ask you this part here, and we'll finish the video. We'll finish the video right after this exam. So let me put the thing back here in yellow. So last example. Let's say this, part E. When is f double prime positive? So now they're asking you to go further ahead, the second derivative. And you're looking at the picture of the first derivative. So I want to make a comment here about these green facts up here at the top. So note that if this is f, this is f prime. But you could always rename these guys. Here's what I mean. If you were to call this f prime, then this would become f double prime. If you were to call this f double prime, this would become f triple prime. You could always name it as long as this one, as long as the second one is a derivative of the one over there. You could always rename. So I want to do that because here they want me to talk about the second derivative. We want the second derivative to be positive. So right here, let me put a little hash mark. So if this is the second derivative, this would have to be the first derivative. So I've updated this guy here. So I want to know when the second derivative is positive. Well, the second derivative is positive when the first derivative is increasing. So when is, and you're looking at the picture of the first derivative. When is this guy increasing? It's increasing all up until you hit the vertex, which we said was at -1/2. So the second derivative is positive when the first derivative is increasing. You're looking at the picture of the first derivative, and it's increasing up until here. So it's increasing before we reached -1/2. So that would be the answer to that question. So for all these situations, it all depends on the graph that you're looking at. Are you looking at f? Are you looking at f prime, f double prime? And do they want you to describe the increase, decrease of f prime? The possibilities are endless. So just keep track of what they're asking and which picture you're looking at.